Every galaxy in the universe spins. Gas falls inward, gravity takes hold, and the whole thing starts to turn. It's what galaxies do. The James Webb Space Telescope just found a giant one that doesn't. Its stars don't orbit in any ordered way. They drift in random directions, going nowhere together. That alone would be strange. But here's the part that breaks the rules. Galaxies only stop spinning after billions of years of violent collisions. And this one had already stopped when the universe was less than a third of its current age. It shouldn't have had the time. So either we're wrong about how galaxies grow up, or something extraordinary happened to this one. Fast. So why is spinning the default? A galaxy is born from an enormous cloud of gas collapsing under its own gravity. As it falls inward, it spins up. The same way a figure skater speeds up when they pull their arms in. That spin organizes into a flattened, rotating disk with stars and gas orbiting the center in the same direction, like horses on a carousel. The Milky Way does this. Andromeda does this. Almost every galaxy you've ever seen a picture of is a spinning disk. Rotation is the signature of a galaxy that formed in an orderly way and has been left alone. But there's a second kind. In the nearby universe, the largest galaxies of all, giant ellipticals, don't spin like that. Their stars don't orbit in neat circles. They swarm in random directions, like a cloud of bees instead of carousel. Astronomers call these slow rotators. And we know how they get that way. They're the survivors of chaos. Over billions of years, these galaxies collided and merged with others, again and again. Each collision scrambled the ordered motion a little more, until the neat spin was gone, and what was left was random. It's a very slow process. It takes most of the age of the universe. That's the key fact to hold on to. Now meet the galaxy. It's catalogued XMM Vid1 2075. I'll just call it X2075 from here. And we're seeing it as it was when the universe was less than 2 billion years old, less than a third of its current age. A team led by Ben Forrest at the University of California, Davis, had already flagged it using the Keck Observatory in Hawaii as part of a survey of the most massive ancient galaxies. They knew two things about it. It was huge and it was already dead. Huge in this case means several times as many stars as the entire Milky Way. Hundreds of billions of suns, all packed into the early universe before there was much time to build them. And dead means it had stopped making new stars completely. No new generations forming, no fresh light. Just an enormous population of aging stars coasting. For a galaxy that massive to have already shut down that early was strange enough on its own. That's what made it worth a closer look. What the team didn't know was how it moved, and measuring the internal motion of a galaxy this far used to be nearly impossible. At that distance, a galaxy is a tiny smudge, a few pixels of light. JWST changed that. Its resolution was finally enough to clock how the stars inside were actually moving. But how do you measure whether something this far away is spinning? You can't just watch it turn. That would take millions of years. Instead, astronomers read its light. When a galaxy spins, one side is rotating towards us, and the other side away from us. The side coming towards us has its light shifted slightly bluer. The side moving away is shifted slightly redder. Spread the galaxy's light out into a spectrum, and an ordered spin leaves a clean tilted signature, blue along one edge, red along the other. A galaxy with no rotation leaves no such pattern at all. Just a jumble, stars moving away in every direction at once. And this is where the other two galaxies matter. Forrest's team didn't just look at the odd one out. They measured three massive galaxies from the same early era with the same instrument, the same way. One showed a clean, tilted spin signature, a textbook rotating disk. Another was messy and disordered, somewhere in between. And the third, X2075, showed nothing. No rotation at all. Its stars were moving in random directions. A slow rotator. A giant, dead, swarming galaxy of the kind that's only supposed to exist after billions of years of collisions. That contrast is what makes the result trustworthy. The same telescope that found a normal spinning galaxy right next door found this one standing perfectly still. The stillness isn't a limit of the measurement, it's real. And it reached that state when the universe was still young. The clock simply doesn't allow for it. By every model we have, a galaxy this massive, this quiet, and this disorganized should not yet exist. So we're left with two options. Either a timeline for how galaxies stop spinning is wrong, or something happened to it fast enough to skip billions of years. The leading idea is a shortcut. Instead of grinding away its spin through dozens of small mergers over cosmic time, X2075 may have done it in one or two catastrophic events. Picture two galaxies of similar size, colliding nearly head-on, while spinning in nearly opposite directions. Their rotations don't add up. They cancel out, like two spinning tops slammed together until both stop. What's left is a single massive galaxy with no net spin, its stars thrown into random orbits in a cosmic instant rather than over billions of years. That same violence fits the other thing we know about it. A major collision can shut down star formation. It burns through or blasts away the gas a galaxy needs to make new stars. So the merger that killed its spin may also be what killed the galaxy itself, leaving it massive, dead, and still. If that's what happened, this galaxy lived fast and died young. It assembled, collided, and froze, all inside the first 2 billion years. A compressed version of a life cycle that's supposed to take more than 10. But one strange galaxy is just one galaxy. The question that actually matters for our understanding of the universe isn't whether this one exists. It's how many others are out there. Here's why astronomers care beyond the novelty. Our simulations of how galaxies form make specific predictions about spin. They say that cold gas pouring into a young galaxy should carry a lot of angular momentum. It should make galaxies spin, and keep them spinning early on. A massive non-rotating galaxy this early pushes against that. If X2075 is a one-off freak, the models survive. But if galaxies like it turn out to be common in the early universe, then two things in our simulations are wrong at once. They've been overestimating how much spin cold gas delivers to young galaxies, and underestimating how often violent gas-free mergers happen in the first couple of billion years. As Forrest puts it, the point now isn't whether non-rotating early galaxies exist. This one settles that. The point is the population. How many, at what masses, and what environments? So here's the honest state of it. What's confirmed? X2075 is massive, already dead, and shows no rotation, at a time when the universe was less than 2 billion years old. JWST measured it directly. That's solid. What's not settled? How it got that way so fast. The counter-rotating merger is the leading explanation, but it hasn't been pinned down for this specific galaxy. And we don't yet know if it's a rare accident or the first glimpse of a whole hidden population. That's the question that decides whether our models need a small patch or a serious rewrite. The way forward is more of exactly this. JWST can now do these motion measurements on distant galaxies that were impossible a few years ago. As it surveys more of them, the statistics will come in, and the early universe will either fall back in line with our models or force us to change them. We assumed spinning was simply what galaxies do, and that the great still, dead giants were the slow work of more than 10 billion years of collisions. Then JWST found one that was already still when the universe was barely getting started. Maybe it found a shortcut. One catastrophic collision that did in a moment what usually takes an eternity. Or maybe the quiet motionless galaxy drifting at the edge of cosmic time is telling us that our story of how galaxies grow up has a gap in it we never noticed. Either way, it shouldn't have been there, and it is. If this one was worth your time, a like genuinely helps the channel grow. Subscribe for more of these. Thanks for watching. Clear skies.